last time we ended class by talking about our values of sine, cosine, and tangent at basically the axes. Okay, so when we rotate to the positive x, positive y, x, negative y, what values do we end up getting? And we use kind of those impossible triangles as a way to kind of explain those values. Um, and so we had all of these. So first, if you don't have these filled out, fill them in as you do have some math Excel questions relating to this. Um, and this can be just a really helpful way to work through some of those math Excel questions. We're going to also kind of add on to this once we start building the unit circle, as all of these rotations do show up on the unit circle. So we're going to get more practice with this the second half of the notes today. Okay, so first I'm just going to give you a minute to jot this all down, and then we'll kind of move forward from there. Okay, so go ahead and write. So the next thing, and this is another really important piece of, sorry, we're frozen, of the unit circle, is knowing which trig functions are positive and negative in each given quadrant. Okay, so one way to kind of remember this is all students take calculus. Now, what the heck does that even mean? Well, in our rectangular grid, we have 4 quadrants that I don't think we've explicitly defined yet. Quadrant 1 is where both x and y are positive. Quadrant 2 is where x is negative and y is positive. Quadrant 3 is where both x and y are negative. And quadrant 4 is where y is negative and x is positive. Okay, now in each of these quadrants, our trig functions, so whether that be sine, cosine, tangent, or even the reciprocal functions, are going to either always be positive or negative. Okay, and this is something that, again, we'll touch on when we get to the unit circle. Now, to kind of explain this, I want to take another kind of triangle, for example, and using that work that we had kind of used before. Okay, so let's make a triangle right here in quadrant 1. Let's call this angle theta. And let's say that we rotate to a specific point. So we have x comma y. Okay, kind of like the work we had done yesterday. When we get to that specific point on x comma y, remember we built those triangles, and we kind of built them more as a way to kind of work through the problem. I told us that the triangles aren't real because a lot of times we get negative values, and that's going to happen. So even though we can use the triangles, they're not always necessarily real and valid triangles. But with this, if I use this triangle based on this point here, when we agree based on our work from yesterday that this horizontal leg is equal to the x coordinate there, and this vertical leg is equal to the y coordinate. And then let's just call the hypotenuse, I'm just going to call it r, and we'll kind of come back to that. But let's look at what happens. You know what? I'm going to let r equal 1. Let's let it equal 1 in this particular case. And that's going to be related to the unit circle, and it just will kind of help prove this point here. So let's think about if I were to take, let's just use our 3 basic trig functions, sine, cosine, tangent of this angle, how they correspond to these values. Well, sine of theta is equal to the opposite over the hypotenuse, the opposite being y, the hypotenuse being 1. So in this case, when we have a hypotenuse of 1, that means that sine of theta is just the y coordinate. Cosine of theta, being the adjacent side over the hypotenuse, is x over 1, which is just x. And then tangent of theta is the opposite over adjacent, which is y over x. Okay, so using this idea kind of helps explain why our trig functions are positive and negative in each quadrant. Okay, in quadrant 1, they're all positive, so all functions positive, because x and y are both positive there. In quadrant 2, sine is the only function that's going to be positive. Okay, sine and its reciprocal being cosecant. So that's where the s comes into play. So s being sine and its reciprocal cosecant are positive. Okay, so the S in all students, that students is saying sine and cosecant are positive in quadrant 2. In quadrant 3, since x and y are both negative, the only function that's going to be positive is tangent, because all other sine and cosine that just have x or y are going to have a negative value there. Okay, so in quadrant 3, the t stands for tangent and its reciprocal, cotangent, are positive. And then in quadrant 4, where x is positive but y is negative, cosine and its reciprocal are going to be positive. So that's cosine and secant are positive. Okay, so again, all students take calculus. That's going from quadrants 1, 2, 3, 4 are a way to kind of help for which trig functions are positive or negative. The other way is thinking about it in terms of these x and y values, which again, we'll kind of solidify and do more work with that with the unit circle lesson coming up later today. All right, so as of now, any questions here? Yeah, Luis? That's cotangent. That's cotangent. So the reciprocal of tangent, because it would be x over y, we get that negative divided by negative. Okay. So we're going to use the all students take calculus to just kind of brainstorm different kind of answers here. And you know what? Why don't we do this in our groups? So thinking about which trig functions are positive in quadrant 2, I kind of explained that. Just again, kind of use that. See if you can do it without referring back to it. Which trig functions are negative in quadrant 3. And then for C, that's kind of like somewhat like an identity. You have to kind of piece together a couple pieces of information to figure out which quadrant it's referring to. Okay, so go ahead and work through those on your own or in your groups, and we'll talk through these. And then just a couple more things before we close out these notes. All right. A and B are basically just what we just explained. So sine and cosecant are positive in quadrant 2. That's again because they typically relate to that y coordinate and y being positive in those quadrants. In quadrants 3, it's basically all except for tangent and cotangent. So you could have said all but tangent and cotangent. And then in C, it's saying that sine of theta is negative. So that automatically kind of rules out quadrants 1 and 2, since sine of theta is kind of equal to the y value. Tangent of theta being negative rules out quadrant 3, because in quadrant 3, both coordinates are negative, making it positive. Okay, so that has to be quadrant 4 in part C. All right, everyone good there? Okay. One last thing, this is kind of using what we know about trig functions and triangles, and then also in different quadrants to try to find other values here. So it says, find each value of each of the remaining trig functions of theta. And so we want to, again, kind of use triangles here. So it says sine of theta equals 7/25 in quadrant 2. Okay, so in quadrant 2, so we're somewhere out in here. We've rotated some theta amount. And before I kind of label all this, I'm going to make a triangle here. And I'm using the fact, that should be a right angle, that sine of theta is equal to the opposite side over the hypotenuse side. So the hypotenuse here is 25. The opposite side is 7. Now the reason that that quadrant 2 is important is because that's telling us that this horizontal leg here is going to be negative, right? That's how it ends up working out to be in quadrant 2. Okay, so we just need to remember that when we use the Pythagorean theorem to find this x, it does need to be negative. So I'm going to use the Pythagorean theorem. So 7 squared plus, let's call it x squared because that is going to be our x value here, equals 25 squared. And just to save us some work, I'm going to just use a calculator here. So 25 squared minus 7 squared is 576. Let's see if that's a perfect square. It is. It's 24. So x squared 576. And so x equals 24. Okay, but again, when we take square roots, it can be positive or negative. And that's where being in quadrant 2 helps us decide that it is negative. And then from here, it's just like the work we did yesterday. So cosine of theta is the adjacent side over the hypotenuse, so negative 24 over 25. Let's find its reciprocal. So secant of theta is the hypotenuse, so 25 over the adjacent side, which is negative 24. Tangent of theta is opposite, so 7 over adjacent, so negative 24. Cotangent of theta is adjacent, so negative 24 over 7. And then the only other value we do not know at this point is the reciprocal of sine, which is cosecant. So cosecant of theta is 25 over 7. All right, why don't you all do B and C? And then we'll do a 5-minute break after that. You know, I want to show us one thing with this. With this being tangent, it kind of throws another wrinkle in there. So here's kind of what I'm concluding is that I'm concluding that since tangent of theta is negative, that's telling me I'm either in quadrants 2 or 4, because in quadrants 1 and 3 is where tangent's positive. And the fact that cosine is positive is telling me that x needs to be positive. Okay, so I know that I'm in quadrant 4 here, and that's going to help me label this triangle here. So now I can think of, we have a point here, and that point is coming from, we have opposite and adjacent sides. We just need to think about which one's negative. Well, since we're in quadrant 4, x is positive, okay, and the opposite side from this angle theta is y, so this needs to be negative 1, and the x is going to be positive 3. Okay, so even though that negative is kind of, right, when we first write tangent of theta equals negative 1/3, we're not seeing any specific place where that negative is needing to go. Okay, but cosine of theta being greater than 0 tells us that this horizontal leg is positive and this vertical leg is negative. Right, so hopefully that helps you a little bit. Now take it from there, finish part B and part C. Right here, but C is a little bit harder. Okay, so part B, I kind of gave us our hints. Again, really kind of thinking about which quadrant we're in, and that's going to help us with the signs are really important. One kind of note here, and this won't make a heck of a lot of sense until after our unit circle lesson, but this hypotenuse length will always end up being positive. All right, so we'll get to that more in our next lesson here. So that's always positive root 10. So then with our simplifying, there's a little bit more to do because we have that square root and knowing that we can't get square roots in our denominator. Okay, so using the triangle, you find sine of theta to be negative root 10 over 10 once simplified, cosecant to be negative root 10, cotangent to be negative 3, so that's just a reciprocal of negative 1/3, and then cosine being 3 root 10 over 10 and secant being root 10 over 3. And any questions about where these values are coming from? Okay, happy to go through any of the ones that we aren't quite sure where those values are coming from. Okay. So part C, I just want to kind of show us kind of the start for it. And then I do want to make sure that you have some time to work through these. And it's important that when I give you the time to work through these problems that we're actually trying things. Okay, I don't need them to be perfect, but you do need to try these problems when I'm giving you the time to do so. Okay, if you just wait for me and copy them down, it's not going to do much. Okay, in fact, it hardly does anything at all. So make sure if we give you time to work through these problems, you're actually working through them, and even better, discussing them within your groups. All right, so part C. The fact that secant of theta is negative 3, I know that secant of theta is a reciprocal of cosine. Okay, so it's going to be the hypotenuse over the adjacent side. Well, negative 3 isn't a fraction, so I'm not quite, there's no obvious thing that tells me what the adjacent side is. Well, to get negative 3, that's the same thing as negative 3 divided by 1. So I'm going to put that over 1 to help me figure out what my adjacent side and hypotenuse are. So I have one of those being negative, and I don't know which one yet. Well, tangent of theta is greater than 0. So we are in a quadrant where tangent is positive, that being quadrants 1 and quadrants 3. Because secant is negative, we have to be in quadrants 3. And so with this being hypotenuse over adjacent, again, the hypotenuse will always be positive. So that 3 makes the hypotenuse positive. The adjacent side is the negative value, which is -1. And then I have to use the Pythagorean theorem to find that opposite side. That opposite side ends up being √8. And since we are in quadrants 3, it's -√8. Okay, and that's, again, a really kind of important and sneaky part of this. Okay, so it's -√8, which simplifies to -2√2 after we take out the perfect squares. Highly recommend that you do take out and simplify those perfect squares before you move forward with this. All right? Questions here? Caroline, you had your hand up. Yeah, you're exactly right. So with secant of theta equaling the opposite, not opposite, it's the hypotenuse over its inverse or reciprocal of cosine. So it's the hypotenuse over the adjacent side. That gets you? Okay. Yeah, and just again, kind of what I talked about here, right now with secant of theta equaling -3/1, remember, it doesn't matter where that negative goes. Okay, if it's -3 divided by 1, that's still -3. If it's 3 divided by -1, that's still -3. What helps us decide where the negative goes is which quadrants we're working in. So the fact that I'm in quadrant 3 is what's telling me that this adjacent side is going to end up being negative because the hypotenuse is always positive. Okay, and you know what? Let's just get these last values in, and then we'll take our break here. So now using that triangle, you find sine of theta to be -2√2/3, no simplifying really needed. Cosine of theta being -1/3, again, no simplifying needed. But now with cosecant, when I take the hypotenuse of 3 divided by the opposite side of -2√2, I need to get rid of that square root in the denominator by multiplying by √2 over √2. So it's 3√2 over -4 after simplifying. Tangent, I know it needs to be positive because we're in that quadrant 3, so that's just 2√2. And then cotangent, after simplifying, you get √2 over 4. Okay, that is everything for this last lesson. The Math Excel, you now have all the tools to be able to work through that. These problems will be kind of tricky, so be willing to kind of struggle with them. If you get them wrong, redo them, okay, and really kind of think your way through them based on the signs of what all those values need to be.